Database is the collection of logically related data. So banking, which include the details of customer information and day-to-day credit and debit transaction. In physical data independence, the structure of the data file stored in the catalog separate access from the program. Database designer are responsible for designing the database. Hello everyone, welcome to another session of Dbms. I am Soundarya from CS Department, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. So today let us see the first unit of your Dbms, that is database architecture. Before knowing what is Dbms, let us see what is data. Data is nothing but the collection of raw facts, which includes a name, address, image, audio, video. Suppose if I say Mohan 25 MYSURU, which is a raw fact. When I say information, it is the processed data and gives something meaningful. That is information. So Mohan is a name and 25 is the age and MYSURU is a place. So which is information, which gives a processed and something meaningful, turns the data into something meaningful. That is information. Next is database. What is database? Database is the collection of logically related data. So logically related data, I can say, suppose if you take library management system, which include the details of library itself, not the details of employee salary, no, which include the details of logically related data, that is database. Next is, what is database management system? Database management system is a software that allow creating, defining and manipulating the databases, allowing the users to store, some process and analyze the data easily. So in database, we create, insert and delete and manipulate the data. That is database. It's the collection of logically related data organized in a way that data can be easily accessed, managed and updated. So which is a logically related data which include the details of that particular thing. Suppose if I say employee, which include the details of employee, that is database. Next is applications. What are the applications of database? Where will we use database? I say banking. So banking, which include the details of customer information and day-to-day credit and debit transaction in banking. And water meter billing. If you want to pay bills, so that is water meter billing. Railway and airlines, which include for the reservation and time scheduling, that is for railway and airlines. Not only these are the applications, there are many applications: student database, telecommunication, sales, industry. These are all the few applications that we use a databases. Next is characteristics. What are the characteristics and purpose of database approach? So there are four. One is self-describing nature of database system. So we have traditional file system where the data are stored in the form of paper and pen. So usually we are writing, that is traditional file system. So after DBMS, we store data, that is metadata. So metadata describes the definition of the database. Say for example, I say student. So in student table, we create roll number, name, course. So here, which includes metadata. Metadata describes or defines the database structures and the information are stored in the catalog. So this is the database structure, that is called metadata. Next is insulation between the programs and data abstraction. So here we see what is data abstraction and insulation between program and data. Here there are two things. One is physical data independence and physical operation independence. In physical data independence, the structure of the data file stored in the catalog separate access from the program. In physical operation independence, there are two interfaces we see. One is interfaces includes data types and its argument, and the implementation cannot be changed without affecting its argument. And data abstraction that allow program data independence and program operation independence. It does not contain the details of how data is stored and how the implementation takes place. Next is supports of the multiple views of the data. So how DBMS support multiple views of the data? It contains a subset of the view and contain virtual data derived from the database and which is not explicitly stored. And when it comes to multiple views, it allows the multiple users to access the data and provide facilities for the multiple view. Next is sharing data and multiple user transaction processing. So DBMS allow multiple users to share the data and access and also manage information. Next is what are the advantages of DBMS? So control data redundancy. Next is data sharing. It shares the data and maintenance is easy, reduce time, backup and multiple user interface. Next we have people associated with the database system actors on the screen. So who are the people are associated with DBMS? First is system analytics. System analytics determine the requirement of the business and provide a solution for the technical and non-technical. So database designer. Database designer are responsible for designing the database and application programmers. Application programmers are the professional who implement the specification by the system analytics. Next is end users. So end users have the various types: casual end users, parametric end users, sophisticated end users and standalone end users. So in casual end users, they are the users who uses occasionally whenever they want. And then comes parametric end users, which are designed for the entire operation. Example, banking, railway reservation, that is for parametric end users. Then sophisticated end users, that is used by scientists, engineering, system analytics, that is sophisticated end users. And standalone, which is used for personal. Next is data model. Data model is the concept that can be used to describe the structure of the database, provides the necessary mean to achieve this abstraction. So which describe the structure of the database and provide the necessary means to achieve this abstraction. Next is categories of the data model. Data model has been categorized into three types. One is high level or conceptual data model, representation or implementational data model, physical model or low level model. First is high level or conceptual data model. It presents the data for the user, which includes entity, relationship and attributes. So entity is nothing but the real world object which describes the employee or the project. In that we have attributes. So attributes include the employee name, salary, employee ID. That is an attribute. And a relationship which describes the relationship between the two or more entities. Next is representation or implementation of the data model. Representational data model represent data structures in the form of records. These are called record data model. Then next is physical data model or low level model. So physical data model represent how data is stored in the file by representing information such as recording, ordering, recording information and access path. Next is database schema. The description of the database called the database schema, which is specified during the database design and it is not expected to change frequently. So here we have two types. One is physical database schema and logical database schema. Next is DBMS architecture. In DBMS architecture, there are three types. One is one-tier architecture, two-tier architecture and three-tier architecture. In one-tier architecture, the DBMS is directly available to the user. That the user is directly communicating with the DBMS. This means the user can directly sit on the DBMS and use it. Any changes done here will be directly done on the DBMS itself. It doesn't provide a handle tool for the end users. So here the user is directly communicating with the user. There is no end user. There is no intermediate between the user and the database. Next is two-tier architecture. So here it's a client side and it is a server side. So in two-tier architecture, we have database system, user and application. So user and the application, they are in the client side and the database is in the server side. Here the user is directly communicating with the database system. And here we use the APIs like Open Database Connectivity and Java Database Connectivity. Next is three-tier architecture. Again here it's a client side and it's a server side. So in client side we have user and application client and in server side application and application server. Here the user is not directly communicating with the DBMS, so the end user has no idea about the existence of the database. Next is data independence. So data independence refers to the characteristics of being able to modify the schema at one level of the database without altering the schema at the next level. So in data independence, how do you modify the schema without affecting the other schema? So here we have two types. One is logical data independence and second one is physical data independence. In logical data independence, we change conceptual schema without affecting the external schema. In physical data independence, we change internal schema without affecting the conceptual schema. Next is database languages. So there are four types of database languages. One is a DDL, data definition language, and DML, data manipulation language, and DCL, data control language, and fourth one is TCL, transaction control language. So data definition language, which is used to define the structure or pattern of the database, which is used to create table, alter, which is used to modify the database, rename, and delete, which is used to delete the table. Next is data manipulation language. So in data manipulation language, which is used to allow and access the database, here we have select, update, insert, and delete. And data control language. So data control language, which is used to store it or save it. Here we have grade and revoke. So revoke, which is used to know the previous database, and data transition control language. In transition control language, used to change made by the DML language. Next is interfaces in DBMS. What are the interfaces we have? First is menu based interface or web client on browsing. In menu based interface, which contain menu type. Say for example, when you go to hotel, you have menu. So in the same way, we have menu based interface, which reduces the time and complexities of the users. And then form based interface. In form based interface, each user has a form they need to fill it. Say for example, Google form. And graphical user interface. In graphical user interface, which represent in the form of pictures and which make use of the menu and form based as well. Natural language interface. Natural language interface, which accept the request written in English or any other language. Speech input and output, which answer to the questions. And interfaces for DBA, that is a database administration. Next is interfaces on the DBMS. Here we have classification of DBMS based on the data model. Based on the data model, we have network data model, hierarchical data model. In hierarchical data model, the data are in the form of tree structures. Say for example, a parent has a child, that is hierarchical data model, and it is for 1 to many. In network, it's for many to many. The parents has many children, that is network data model. So based on the number of users, how many users, there are multiple users and there are single users. Based on the number of sites run on the single database or a database softwares, and based on the purpose. So based on the purpose, which include was a specific purpose like a railway and airlines reservation, ATM, online transaction application. So this is based on the purpose. Thank you.